All right, so we're on page 227, Chapter 6, using arrays. Now, if you look at the objectives that are here, we've already covered most of them. You now know how to declare an array and assign values to array elements. You know how to access array elements. You know how to search using a loop, be it a for each or a for loop. We went through the binary search, the sort, and the reverse methods. I don't even care if Evan has done anything with a two-dimensional array for your next test. I'm not going to. You can have arrays of as many dimensions as you want. Does that make sense? Usually you don't have one that's more than 3 dimensions because it's hard for people to imagine something, or to write a program for something they can't imagine in their heads. All right? But you can literally, if you wanted to, you can have an array of 10 dimensions. I don't know why you would do that, but you could do that if you wanted to. And we'll talk about some of the issues in GUI programs. So again, remember, now tomorrow is what? Tomorrow's Friday, right? So tomorrow's your hands-on for chapters 3 and 4, whole period. All right? And then next week, we're going to kind of do the same kind of thing. You're going to have on Monday, you will have the written test for chapter 5, okay? And then Tuesday, you'll have the written test for chapter 6, all right? And I'm going to give you the rest of both those periods for lab. Then what we're going to do is we are going to do 7 and 8 next week because they're interrelated with one another. They're methods and advanced methods. But I'm going to go back to the same program I just gave you with arrays, and I'm going to take every single thing that we did in there, and I'm going to put it into its own method. All right, so you see how that's done. So you can plan on tomorrow being the hands-on test for chapters 3 and 4, and a week from tomorrow being the hands-on test for 5 and 6. And then we'll do just like we did this week. Next Wednesday, we'll go over the lecture on chapter 7, and I'll show you that example. Thursday, we'll go over chapter 8. Does all that make sense? All right, and like I said, when we get to chapter 9, we'll slow it down, 9 and 10. But then we'll, for which ones? Ideally, what we said was, let's just say 3 and 4, everything through chapters 3 and 4 should be in by this Friday. Then by next Friday, have everything in for 5 and 6. Then the next Friday, everything in for 7 and 8. That should give all of you a big enough window that you should be able to finish everything. Because these are much more complex than the stuff you were doing by and large. In JavaScript last year, or last semester, you may or may not have liked it. Well, you didn't like it. But the point is that a lot of times it was, they showed you this and then told you to do it type of an idea. You know what I'm saying? This is much more, we're going to give you requirements and explain to you what to do. You're going to figure out how to do it. So it's more work. It's harder to do. All right? Now, the other thing we can do next week, the other day, the other 2 days, I went over questions that people had on chapters 1, 2, 3, and 4, anywhere in the chapter. But I did not tape those. Because like I said, Evan assigns these to his students too, so I don't want to put the answers out there. But I'm willing to do that next week on chapters 5 and 6. So look at chapter 5, look at chapter 6, and if there's something you don't understand, then like Tuesday or Wednesday or whenever, we'll go over those. All right. Again, I don't want to be unbelievably repetitive in here. So I don't want to sit there and the author explains arrays in a little bit different way than I did, which is fine, no problem. But they mention this, and again, I don't want to read to you, so take a look at what's in here, in this paragraph right here. Because it's all on the test. The fact that arrays allow you to store multiple values. That's on the test. And ideally, it puts them in adjacent memory locations. That's what it tries to do. That's why you're able to access the array so fast. All right? But let's suppose, remember, I removed that example, but the example that I gave you before, all right, when I said, Scott lives in apartment 1, etc. So let's assume somebody else, someone new moves in, but our apartment complex is filled. All right. So Andrew Abel moves in, but he can't move into that apartment. So we have to make another one. All right. Well, the idea is as you keep doing this and you've got more and more and more, the system tries to use adjacent memory locations. But you've all heard of that idea that, maybe you've had to do this before, that, especially in the olden days, I know this is how old I am, that when you had the floppy disks, all right, if you remember back in the day when they were 5 1/4-inch floppies, all right, yeah, you laugh about that now, that wasn't that many years ago. But the point is, they didn't have nearly the capacity on them that you have now. So you'd store something on that disk, then maybe you'd remove it, you'd store something else, remove it. Then what would happen is you'd have a bunch of areas on the disk where you had pockets that were free. You know what I'm saying? You've got a little space here and a little space here. And typically what you did then was you ran like a scan disk or a check disk or a fixed disk type of thing on it. But when people didn't, you might have wanted something to be in adjacent memory locations, but there wasn't room for it. So the system will always try to store something in adjacent memory locations. But if I asked for an array of size 1 million, which I could do, all right, and whatever it is, each one of those is, let's say, 8 bytes. That's 8 million bytes that it needs contiguous. The system may not have that in its memory. So it'll do what it can, is what I'm trying to tell you. So on the bottom of the page here, there's some, again, I would know all of this stuff for the test. An array is a list of data items in this language. In this language, they all must be the same type. If you remember from last semester in JavaScript, that was not the case. JavaScript, if you remember last semester, you could create a variable. You could say var age equal 21. Then on the next line, you could say age equal Jeff, and it would work. You can't do that here. JavaScript is what was known or is known as a loosely typed language. This is a strongly typed language. That's why all of the elements in the array must be of the same data type. So you can have an array of ints, but they can only hold whole numbers. You can have an array of strings, but they only hold things within double quotes, etc. Each object in the array is an array element, and it's accessed by what's either called a subscript or an index. This is how you create an array. If you did this, just like they show right there, the system doesn't put any space, it doesn't allocate any space. Why? What didn't we put there? What's not there? The items, but it's more even basic than that, the size. So the system doesn't know how big that is. All right? But you can do something like that and then set it up later. Normally you don't do that. In fact, I don't even think you can do that in here. This format is illegal in C#. You can do that in JavaScript. But in C# you have to give it a size right away. You have to. All right. Turning up to page 229. Arrays are typically named in a plural. Remember before when I said for each and I said number in numbers? Remember that? You almost always, when you create an array, put an S on the end. I mean, you pluralize it. That way, if you use a for each, you can use the singular form of it. All right? So there is an example. I don't know why you would do it like this, but I guess you can. All right? This is on the test. The keyword new is what you use to create objects. That's on the test. I know that is. Again, when we get done today, we're going to go over the test review like we've been doing, etc. We're going to do that. But I know that's on there. So you should know, looking at this, and I'm not for a test or anything else, but if you look at where I've got the cursor moving back and forth, you should understand the name of that array is sales. There are 20 elements in it, and the elements will be sales sub 1, or I'm sorry, sub 0, or sales bracket 0 bracket through sales bracket 19 bracket. If that makes sense to you, you're on your way to understanding this. All right? And I'm just going to tell you this, and if I sound like whatever, then I do. But I told Charles yesterday, I said, my biggest worry is there are people in here that aren't reading the book. If you are or you're not, you know that. There's no way you can absorb all this stuff, I don't think, by just listening to me spit out what I think is the most important. If you want to become proficient in this, you have to read the book. All right? Especially this chapter. There's a few chapters in here. This chapter, probably 9 and 10. All right, but this chapter, maybe out of all the ones we've done so far, is the most important. All right. Again, elements, arrays start, the first element in the array is element 0. That's on the test. Right here. Always starts with element 0. It says here in C#, arrays are objects. They use the system. This is on the test. It says what built-in class is used with arrays. It's the system.array class. That's on the test. This is the bottom of page 230. All right. In this language, if you declare an array and you don't assign values, but so I say, if I do something like this, this is good because not every language does this, and it's nice that C# does. So if I come through here and I say bracket, scores equals new int 25. So let's assume there were 25 of you in here. That automatically takes every single value that's in there, scores 0, scores 1, and it sets all of them to 0. Most languages don't do that. They don't initialize the array for you automatically. This one does. But let's say that I had 2,500 scores in here, and let's pretend for a second that this language did not initialize them. You understand what I'm saying? It does not initialize them. Now, then all I'd have to do would be to say for int LCV equals 0, LCV less than scores dot length plus LCV, and then all I'd have to do would be to say this, scores LCV equals 0. That'll do it 2,500 times for me. That's the power of using an array. All right? The fact that you're able to manipulate and work with tons of data with very few lines of code. All right? So automatically numeric fields are set to 0. Character fields are set to null. It's not the empty string because that's what strings are set to. All right? And Booleans are set to false. Kind of like when you think about it, when you probably would initialize variables to yourself. All right, if you were doing it. Again, this is on the test. So these things right here that you see where you give them values, that's an initializer list. You can do it any of these 3 ways. I showed you the 3rd way. Why did I show you the 3rd way? What? Because it's the easiest. I have never seen anyone use either of the other 2 ways, ever, in actual application code. Why should you? All right? And especially this one, because if you put a wrong number in here, you're going to get an error anyway. You should always, when you're setting up, if you're going to use any of these, use them, if you want to say, well, I don't want to use this one, then use the second one. Don't ever put a number in there unless it's blank, unless it's an empty array that you're not going to initialize. Otherwise, never put a number in. Let the compiler do it, because it does it anyway. It's like you've got some kind of a person who walks out and they turn off your car lights all the time. I know, that most of them turn off themselves now, but let's say you hire somebody to do that. Well, then why should you turn off your car lights when somebody's coming out there to do it for you? Type of an idea. So again, this is on the test. I think this is one of the fill in the blanks. So please put initializer list. Be complete. You can do this. All right, and I want to show you something because it's kind of an important thing for you to realize. Okay, I'm going to copy that. I just want to show you this. This is what the author put in there. Okay, and you might think, well, that's kind of like if you did this. Those aren't the same thing. The first one are 5 different characters. They're not one unit, they're 5 different units. The second one is 1 unit. And you may or may not know this, but internally what the system actually does for the second one, for greeting, it does this. It puts a \0 on the end. You don't see that, but it puts it in there because that's the delimiter that says the string is now ended. It's not counted or anything like that. But you get this when you do this. You do not get this when you do that. Plus, you've got all those string functions you may or may not remember. We looked at this. C# string functions. All right, and you start looking through there, and here's a listing of not all, maybe not all of them, but the ones you probably use the most often. So you see all those? All right, 10, 15, 20, whatever it is. You can use those string functions on this. You can't use them on this. It's not a string. And there are very few character functions. All right? Why would you want to do that? The only reason you'd want to do that first one is if you needed to manipulate every character individually, which you almost never need to do. All right? I'm not saying it's impossible. I'm saying it doesn't happen often. All right, how you access array elements. The hardest thing, I think at least, for people to understand, okay? The hardest thing I think for people to understand is 2 things. First, remember this? We just looked at this, right? I said this before. I was talking to Brady, and he was shaking his head, yes, I think he gets it. Fine, but I want all of you to. That LCV is a placeholder. It means the first time through there, it's going to give me the 0th location, then the 1 location, then the 2 location, all the way up till the last one, which is actually numbers.length minus 1. So with those 10 scores that we looked at, it was scores 0, scores 1, scores 2, scores 3, all the way through scores 9. So it's a placeholder. All right? That's an important thing to realize. I cleaned this up just so you see it. Now it looks the way I wanted it to look. So there's the original array. I put the highest, lowest, sum, and average together, sorted in descending, sorted in ascending, and then allow you to search. All right, that's pretty much the way yours should look now when you run it. All right, but since all those things are placeholders, you can grab any element in an array, any element that's in an array, all right, and you can use it just like any other variable. So, you know, when we had those, before when we had the scores, all right, I'm going to just make it real simple. I'm going to say int, bracket, bracket, scores. Let's just say there's 3 people in here. Equals, if I do something like this, okay, then I can manipulate. So if I decide later on in the program, I want to say, oh, that last person did some extra credit. So scores sub 2 equals, now it's an 88. That's legal. This is the entire array. This is an element that's in the array. Do you understand the distinction? Okay. And there'll be more to that, but it's not until we get to Chapter 8, so I don't want to go on any more about it than that. The length property I already showed you. Okay, that's how many elements are in the array. If you go out of bounds, So notice if I were to come back to our program here, if I said this, everybody see that? I changed that from less than to less than or equal to, right here. I get an error. Because now instead of saying 25 elements 0 to 24, I'm saying 25 elements 0 to 25, which are 26 elements. In fact, if I save this and run it, all right, it's giving me an index out of range exception. It's telling me I'm trying to access something that doesn't make sense to the system. All right, again, if you look at it, that, I just got this the other day. Jeff going to Walmart. And I bought this so I had something to put the microphone in. All right, it's like if I have 25 of these, and now I've got a 26th thing that I need to put inside. I don't have anything. All right, the old proverbial trying to shove 10 pounds worth into a 5-pound bag. All right, so you're going to get something like this. This isn't typically as bad in here. When we get into Java next year, it's a lot more often that it happens in Java than it happens in here. But you use the length. Not only that, okay, and I want to mention this to you, because I could have done this program better, okay? Everybody see this? That's in there all over the place in the program, correct? Okay, what I should have done is I should have done this. Okay, why did I do that? Why is that better? I might have Len in there already. I don't know. Why is this better than the way we did it before? That's correct. What Evan just said. If we do it like this, it's got to go back and it's got to recalculate the length every time. But if we do it the other way, where we put len in here, and if I put this to the top of the program, that error will go away. But now it only has to figure out the length once. If you've got something that's not changing in a loop, whatever your test condition is, if it doesn't change, don't put it in as an expression. Put it in as a variable. This is a variable. That's an expression. You understand the difference? You always want the computer to do as little work as it has to do. And it may not even seem like a big thing, but if you're running a program for the government and it's going to count up to 1 billion, you're going to notice a big time difference because you're making it do more work, even though computers can do work a lot faster than human beings can. All right? So I should have changed that. I actually had it and then changed it back. I wish I knew I did that, but I did. All right. Moving up to 234. There's the for each on the bottom of the page. All right? It's called an iteration variable. There's something about for each, so we'll look at that in a little bit. The advantage of using a for each, that's you write a lot less code right there. Oh, yeah. You write a lot less code in there than you do with writing a regular for loop. All right? Now the for each is limited, and they show you this on the top of page 235. If you only want to access some of the elements in the array, you don't use the for each. You got to use a for. That's just the way that it works. So that's the first thing. Second thing, all right, it's read only. So you can't change the array using a for each, or you'll get an error message. But if you just want to iterate through it or cycle through it, so if I wanted to find every score of every test, I could still add them up because I'm not changing the array. So I could use a for each, and that's what I did. All right. There's a you do it on here, creating and using an array. The bottom of 235, a very short program. It's all of 236. It's right here. So again, if this does not make sense to you, key in the program. Key it in exactly, get it to work. Then once it works, make changes to it so it doesn't work. That's a terrific way to learn how this stuff works. All right, is to make errors. All right. Searching it for an array using a loop. All right. what they're showing you, I believe in here first, is they're using what's called a sequential search. All right. So again, I've given this example before, and again, it's funny because all the examples I use now, they're so antiquated. But back in the days when there was a telephone book, all right? And back in the days where literally everybody had their name in a telephone book, all right? So if somebody wanted to call me, they would look through the book. You'd say, well, they find the S's, the SCs, etc. Yeah, but imagine the phone book is not in alphabetic order. So in the worst case, they want to call me, and I'm at, not only am I not at the end of the book, but for some reason I don't have a phone, so I'm not in the book, period. So when you do a sequential search and you've got a huge list, it takes a lot of time. If you've got 1 million elements, typically when you do a sequential search, it takes as many elements as you have in the list divided by 2. So on average, if you've got 1 million items, it's going to have to search 500,000 times. And even though, again, the computer does it quickly, all right, it's still better if you put it in sorted order first and then search. So they show you a sequential search in here, and then they show you how you can use a for loop for that. Okay, I want to show you something because this is on the test in one form or other. So I'm going to create 2 arrays. String, bracket, bracket, grades equal new, string 3. All right. Would you agree that there are 3 elements in each one of those arrays? Would everybody agree with that? So if I come through here and I do something like this, for int LCV equals 0, doesn't matter which of these I use, so I'm just going to use grades. LCV is less than scores dot length. Again, I could use either one of these because the length of each one is 3. plus plus LCV. Now, if I come through here and do something like this, right line. In fact, we'll give these values too. All right. A minus B. All right, so I do a right line, and I say letter grade, we'll just use this 0. Scores LCV. So I've got, oh, that's wrong. That's number grade. Would you agree, looking at that I'm using LCV, my loop control variable, for both arrays? Would you agree with that? I'm using them in parallel, correct? Those are parallel arrays. When they're the same size, so you can manipulate 2 different arrays, they can be the same type, they can be different types. But if they've got the same number of elements, I can manipulate both of them using the same loop control variable. Because there's something on the test about parallel arrays. I don't remember what it is. Yes?
So even though you have scores.length on the other one, because they're the same, it will still be the same value, so it'll work for both?
Yeah, because all this is just a counter. You know, again, I could have manually set it equal to 3 here or whatever. You know, we really should have said. But even if I said here, grades.length, don't say, well, you couldn't use that, those are strings. No, it's how many are there. And there are both 3 numbers, and there are 3 letter grades. So I could have just as easily put in here grades, and it would have worked just fine. All right, did I answer your question?
Yep.
Okay. All right, so they explain what parallel arrays are on 238. All right. Then they talk about searching for arrays, or searching for values, rather. Okay? So please enter an item, 266, and it gives you the price. Okay? And you can do all that kind of stuff. But again, with things like binary search that are built into this language, there's a lot of really cool stuff. So just like we did before with these string functions, all right, if I come back here and I say C# array functions, all right, and I come through here, I'll just go to MSDN, the Microsoft Developer Network, you'll notice there's a lot of stuff that are built in for arrays. So the bottom line is, before you go and reinvent the wheel, take a look in there and see if there is something that you can already use that already exists in there. Oops, that's not what we want. There we go. All right. So how do you improve a loop's efficiency? Well, one way is what I mentioned before. We talked about this. Don't do this. Do this and come in here and say something like int len equal, and it doesn't matter again if you say scores.length or you say grades.length, but do that. That's just a better way to write. I will tell you, all right, because I used to be on interview committees. That let's say that Ethan's applied for a job at MasterCard, all right, and they use C# in some of the stuff that they do, and he's in there and they ask for examples of his code. If he doesn't do it this way, if he does it right there, there's going to be somebody who's going to see that, and they're going to say either A, his teacher didn't know his ass from a hole in the ground, or B, he just doesn't know how to code in the right way, and that's what a lot of companies are looking for. All right, is do you do things in the best way to possibly do them? All right, so you've seen two ways where one is definitely better than the other is, and it's for speed is why one is better than the other. So you can use a while loop to search an array. You can use a for loop to search an array. All right, you can search for ranges. You can do all sorts of stuff in here. I'll let you read that on your own because there's not really anything in there we haven't talked about. Again, this binary stuff, we already talked about that. That's the bottom of 245, and it goes on. So I showed you an example of how to use the binary search method. It had been a while since I'd done it, so how did I remember it? I went and Googled C# binary search method. You grabbed one of their examples and modified it so it did what I wanted it to do. But that was the example that you saw in here. The way that you use this, all right, this is the array you want to search. That's the value you want to search for. All right. If it finds the value, then index will hold whatever array element number it is. If it doesn't find the value, it'll return a negative number. That's just how the function works, or the method. That's how it works. They give you an example in here, and maybe it's better than mine. I don't know, but it's on 245. 246, 247. On 248, they show you the sort method. This is one people screw up because most people want to say something like, that's the name of your array. All right? And you just say array.sort with the name of the array. That physically changes the array. So that array that's got Olive, Patty, Richard, Ned, and Mindy now becomes Mindy, Ned, Olive, Patty, and Richard. It now is in ascending order. When I showed you the stuff in ascending, we use numbers, but they don't have to be numbers. You can sort strings too. It's not a problem if you got a list of names or cities or whatever. All right. If we do the array.sort like this, and if the next line we put in here, so if I hit enter, if we were right there and I hit enter and I put in the next line where the 4 is, I put in array.reverse names, now I'd have it in descending order. All right. Yeah.
Do you have to have the array.sort names first?
You have to sort it first because all reverse does is it takes whatever you got. So if we had this and we ran reverse on this, okay, it would be Mindy, Ned. It wouldn't be in the right order because these three would be wrong.
Right.
Okay. Gotcha. All right. And they talk about a little of that stuff. Again, system.array. It's on the test. Reverse, we've already looked at. 249. Again, if this confuses you, look please in the book on page 250. Another you do it, where it's on 250, 251, and 252. So they have you enter in a bunch of scores. They show them in original order, then they sort them in reverse order. The reverse is really important when you're working with numbers because a lot of times you want to go from high to low. So if I wanted to see which salesperson had the most sales, I would want to do it a sort and then a reverse. All right, multi-dimension arrays, again, I already mentioned them. That's what that's the numbering scheme right there. This is on the test. The word rectangular array. If each row has the same number of columns, it's a rectangular array. If they don't have the same number of columns, I think it's on the next page, then, well, it's in here someplace. You're going to see it in just a second. If they don't have the same number of columns, it's called a jagged array. Jagged. Both rectangular array and jagged array are on your test. Rectangular is on 253, and jagged is on 256. A jagged array is a one-dimensional array where it says here where each element is another array. The point is, with a jagged array, each row can have a different number of columns in it. All right? Again, there's some good examples in here. There's a good example program on 255 right here. So if you're confused, take a look at the program. All right, we're just about finished. Array issues and GUI programs, we're on page 258. It says, the major unusual consideration when using an array in a GUI is that if array values change based on user input, the array must be stored outside of any method that reacts to the user's event. What? In English, what they're saying is, when you declare the array at the top of your program, in a GUI program, you can use it anywhere down below. Okay? That's the key thing. And if you say, I still don't get it, you're going to see it because we're going to go through an example of it next week. Again, another example, program on 259. So, you should know the keyword new is used if you want to create, a new array, unless you use an initializer list, that arrays are part of the system.array class. You should know what length is. That's the length of the array. The number of elements that are in it is length. They go from 0 till length minus 1. This is on the test. The first element is element 0. The last element number is number length minus 1. Again, the length automatically holds the array length. You should understand what binary search is. You should understand what sort is and what reverse is. All three of those are on the test. So here's the definition for an array, an element, a subscript, an initializer list. Those are all on the test. Sequential search, I think, is on the test. I know parallel array is. Binary search is. Rectangular is. Jagged is. All right? Let's do this a little bit differently. Let's go over the review questions right now. We'll take a break. When we come back from the break, we'll go over the test review. All right? So I'm going to give you these right now. So I don't know how you do it, if you write in your book or on a piece of paper or someplace else. Found out last time that I don't necessarily agree with everything that Farrell puts in for her answers. So. All right. In an array, every element has the same data type. So number 1 is B data type. Number 2, the operator used to create objects is, and that's almost the way it is on the test. So new is the one you want to select. There is no create, so please don't anybody choose that one. All right? Sometimes she puts in words that are similar, And sometimes you guys put those words in even though there's nothing like that that exists in the language. So number 2, 1 is B, 2 is C. Number 3, an array of 6 integers, you would set up like this. So 3 is D. Number 4, the value you place within square brackets can be referred to as a subscript or an index, but it must also always be an integer or an expression that becomes an integer. Okay? So what they're saying is whatever goes within those brackets is called either a subscript or it's called an index, but it must always be something that reconciles itself to an integer, a whole number. So you can't have bracket 3.14159 bracket. That doesn't make sense to the system. Number 5, if you define an array to have 10 elements, the highest element will be 9. What's the first element? 0. So the last one would be 9. That's the old, I've said this to you last semester. It's the old programmer's joke. You tell a programmer to count to 10, they go from 0 to 9. All right? Number 6, initializing an array is optional. In most programming languages, it's required. You know, because we looked at this, if you don't initialize a numeric array, it's automatically initialized to all zeros. Strings are to all empty strings. Booleans are all false, etc. All right, so 6 is B, optional. 7, when you declare an array of 6 doubles but provide no initialization values, the value of the first element is, and they've got unknown. I don't agree with that. Using their logic, it should be 0.0. If that question's on the test, you all get it right, as long as you don't put 1.0 or 5.0 down. All right? Number 8, which of the following declares an array of 4 integers? Again, you could use any of those, but the recommended way is the last way, because as Tiffany said, it's the shortest. Why not use the easiest way where you do the smallest amount of work possible? So number 8 is D, all of these. Number 9, if you say that an array is initialized with an initializer list of 20, 30, 40, and 50, ages 1 would be the second value, which is 30. It's that one. There it is there. Number 10, when the ages array is correctly initialized with these, it's undefined. Why is that undefined? Technically, there isn't one, right? Because it's 0. Oh, give me a break. I didn't touch it. It's 0, 1, 2, 3. So there is no ages sub 4. All right? Good way to get the program to blow up. There are 1, 2, 3, 4, 5, 6 elements in here. So the temperature.length would be 6. So number 10 is D and 11 is B. 12, which of the following doubles every value in a... Oh, that's just a stupid question. The answer is C, both of them. That's fine. 13 is neither of them. Again, I hope the hell she didn't put a question like that in there. I don't think she did. I never would. All right. 2 arrays that you use with one another that store related information like I showed you before with the letter grade and the number grade, those are parallel arrays. I guarantee you that some question on the test has parallel arrays on it. They say which would show these in reverse. I would never do all that work. I would just run the reverse function. But 15 is B. 16. Descending order, you do a sort, then you do a reverse. So number 16 is C. 17. Both binary search and sort and reverse are all parts, they're all things that belong to the system.array class. 18, if you use the binary search and you don't find it, a negative value is returned. Not -1, it could be, but it could be any negative number. That's why I made that test in here, where I check for less than or equal to 1, or equal to -1. Question? I skipped 17? It's B. All right, 18 is D. 19, the binary search method is inadequate if you've got duplicate values and you want to find every occurrence. All the binary search does is it finds the first occurrence. So if I want to know how many people got 100 on the test, all right, it'll find the first person who got 100, but not every person who got 100. And number 20, so 19 was B, number 20 is D. And that's if you're working with a two-dimensional array. Notice when you put that in there, you do need the comma. That shows that there's two values, one to the left of the comma and one to the right of the comma. All right, it's 10:02. Let's come back at 10:15, and we'll see if we can take around 15 minutes or so. What I'm going to do, if you look up here, let's see, I'll have to find it. I don't want that. Kind of do this in reverse. I've got all the answers here, but especially for those of you who are a little typing challenged, what I'm going to do is, that's all of them there. I'm going to put that page up there now. Take your break. All right, some of you stay in here during the break, so if you want to go to the end, you can put this stuff in there right now. Hopefully that'll speed it up when we get to the end. All right? Now, it'll stay up there, but I want to stop taping right now, and I'm going to start in a couple more minutes.